I gave exact same prompt to 10 frontier AI models. No retries, no helping, no second chances. A real project, find a smart switch on my home network, control it, pull a live camera stream, run human detection on it, wire it all into a presence-based automation. Real network, real hardware, real money on the line. One model declared a project complete in 6 minutes, and literally none of it worked. Another finished the entire thing for 75 cents. The most expensive model burned through $3.43 and still couldn't get there. By the end of this video, you'll know exactly which models are worth your money for agentic coding work and which ones to stay away from. Let's go. Hello and welcome back to the channel. I'm Pranjal. 10 frontier models, 1 prompt, 0 retries. Ran on OpenCode. Same harness for every model, neutral ground. About 15 minutes, I'll walk you through every run and end with my honest verdict. Why am I doing this? We need to compare these models on real world tasks with real money on the line. That's what actually matters. Everything else is fluff. All the benchmarks, all the leaderboards, all the launch day blogs, that's secondary. I want to know which model picks up the multi-step project, plans it, executes it, and gets it to end without me holding its hands. I ran every model through OpenCode. Same harness, same tool, neutral ground. I love OpenCode for this. It doesn't favor any provider. Here is what you're getting. The exact prompt I handed every model, verbatim. I will put the prompt in description so you can copy it. What each model did, the pros and cons. Then I provide the numbers from each run. Time, cost, did it actually finish it in one shot? My honest interpretation, and at the end, my final verdict on which models I'd actually reach for. The task, 1 smart Wi-Fi switch on the LAN, 1 RTSP camera at a given IP. The agent has to find the switch on the network. As there is only 1 smart switch, it should not have issues, and then it needs to control it. Once that's done, it needs to pull the camera stream, run human detection on it every 30 seconds, then wire all of that into a presence-based automation. When the human is present on the camera feed, turn the switch on. If no human found for 5 consecutive minutes, turn the switch off. Now this is the exact prompt given to the models. They need to read all the tasks first, plan, then execute in order. Document every decision in project.md file. Don't stop to ask. The user evaluates after completion. 6 tasks. The last one wires everything together. This is exactly what every model received. Pause to read the prompt. As already mentioned, the same prompt is given in the video description as well. Now getting into the runs. I'm grouping the models by region because the regional differences turned out to be interesting. We start with top models from US labs, namely Anthropic, OpenAI, XAI, and Gemini, and then I tested Chinese frontier models. Same prompt, same harness. Anthropic first. The 2 models in this run, Opus 4.7 and Sonnet 4.6. Opus 4.7. This one worked like it already knew the playbook. Decisive, documenting why each decision was taken as it went. Felt professional, treated the task as a piece of cake. It carried out the task really quickly. It took some interesting decisions that made the project work in one go. Was able to find the smart switch very quickly and was able to automate that without wasting any time. It used mobile SSD for human detection. Directly, as we will see later, that other models tried many other AI models for human detection, which did not really work well for them. This model was able to detect human feed accurately every single time. The output from the model was very detailed, and at times same details were repeated multiple times. And maybe that's where the cost of execution of this project went to $2.40. However, the model was able to complete the task just in one shot, and everything just worked. Sonnet 4.6, it was super thorough. Went end to end with live status updates, diagrams, IPs, and identifiers called out as it went. I was completely blown away by the reporting quality. It did detailed checks for smart switch provider and did a cross-reference as well. It set up 3-tier human detection cascade, YOLO V3 tiny as primary, hog as secondary, and har as tertiary. Often, even after adding these detection models, the human bounding boxes were sloppy, as you can see in the image. Multiple boxes that didn't quite cover me, versus Opus's perfect single box that you saw in earlier slide. It was about 10% pricier than Opus and took almost twice as long as Opus to complete the task. But it ran more comprehensive live tests, where it ran the test for more than 6+ minutes to verify all was working perfectly. Felt like thorough professionals showing all of their work and verifying it. Next, moving on to OpenAI's models, we tested GPT 5.5 and 5.4. GPT 5.5, almost equally as good as Opus 4.7 overall. Methodically professional. Identified the switch and brand quickly, saved everything, moved on. It took roughly 15 minutes. At $1.46, it was meaningfully cheaper than both Opus and Sonnet on the same job. The cost win seems like token efficiency. Where Opus and Sonnet models spit out heavy documentation, GPT 5.5 stays minimal. Same task, fewer output tokens, lower bills. It refused to download a 30 megabyte model when Hog would technically run, but documented the detector as swappable. It seems privacy conscious. While documenting the project.md, it removed the key provided for the smart switch. There is one real caveat here though. Human detection worked well when I did a bounding box test, as you can see in the image, but subsequent tries failed in the live test. Couldn't detect me sitting close to the camera. Overall, the task was done reasonably quickly and methodically in one shot, but a point was deducted for the live test failure. Now moving to GPT 5.4, the cautious cousin of 5.5. It used the same Python tech stack, but slower, more verbose, and less willing to make decisions without a nudge. 18 minutes, $1.91. Noticeably more than GPT 5.5 for same outcome. Got there, but a long way around. The on-whiff camera identity was actually the best of any model. It pulled out the serial number and the hardware ID and exposed both as separate identity anchors. Even Opus stopped short of that. Where it fell down was detector choice. It stuck with Hog and Har cascades through the main pass, even though they weren't working on the live angle. Pipeline was effectively broken on human detection until I prompted it. When pushed, it self-corrected and installed a better detection mechanism. Re-verified at a 0.88 confidence, strong recovery, but required re-prompting. Now moving on to Grok 4.3 from XAI. It was released recently, so I had very high hopes with this model. I was expecting it to perform at GPT 5.5 level. However, something very different happened. Grok 4.3 was the fastest one to declare victory in the entire run. 6 minutes to the stamp, the project complete with ASCII Arts celebration. Then I tested it. None of it worked. It never controlled the smart plug, never opened a real RTSP stream, never produced a usable bounding box. When I pushed on why it didn't find the plug, the reply was, and I'm quoting, "I've written the robust code. It's a lab environment. You don't have those IoT devices." It assumed there was nothing to find. Even after being told that other models found the device, it scanned, got stuck inspecting the router's IP, never moved on. It also hallucinated camera authentication as well. Kept demanding RTSP credentials when the camera had no auth. Almost $2 to produce nothing functional. This model failed the test completely. Did not perform any of the tasks even after repeated requests and nudges. Then came Gemini 3.1 Pro from Google DeepMind. Gemini 3.1 Pro was the cleverest opener of the bunch. Inferred the brand of smart switch from 16-character key length. Correctly identified Tuya before scanning anything. That was a genuinely smart move. But then it assumed it was running in a sandbox and skipped the real work. Wrote shell code, declared the project complete. Did not actually probe the LAN at all. Only after being told the plug is already there on the network, did it scan, find the device, and toggle the switch. Same pattern repeated for camera and detection. The real win is the multimodal advantage. As the vision capable model, it could see its own bad bounding boxes, recognize the problem, and upgrade to a CAF SSD DNN and hit 94% confidence. The other models can't lean on that. Final cost 216, but only 17 cents on the first pass. The rest was corrective pushing. It seemed like the cleverest model in the room, but least autonomous executor. And now moving on to Chinese models. 4 models, GLM 5.1 and 5 from Shifu, Kimi K 2.6 from Moonshot, and DeepSeek V4 Pro. GLM 5.1, this came in as a professional and did everything. Looked like it knew exactly what needed to be done. Quickly identified the switch, controlled it, moved cleanly to CCTV, and finished. No drama, no mock fallbacks, no excuses, no sandboxes. Just executed. The biggest shocker was the price. It took 75 cents total, by far the cheapest of any models tested. Roughly half what GPT 5.5 spent, about 1/3 of Opus. Finished first pass, no corrective rounds. It took right defaults the whole way. Tiny Tuya, Hog, stored device ID, MAC, local key, and protocol version. Auto reconnects with by device ID, so IP changes don't break it. The Hog bit is interesting. Same detector that didn't work for GPT 5.5 produced a correct bounding box here, almost certainly because GLM tuned the parameters and run non-max suppression on top. This model gave best price to performance for any model tested by a wide margin. GLM 5, the older Shifu model, roughly on par with 5.1 in behavior, but both felt about as professional as each other. 25 minutes, cost $1.08, second cheapest of any models behind its successor. Started simpler than needed and escalated correctly based on the task at hand. It used ping plus ARP resolution first to find the smart switch because no sudo was required. Then went on to port fingerprint, and then Tiny Tuya only after handcrafted attempt failed. Each step a sensible escalation. Recognized OpenCV RTSP would fail and went straight to FFmpeg subprocess. It used the same hog plus har recipe as 5.1, but produced a sloppy bounding box where 5.1s were correct, probably a parameter tuning gap. Quietly impressive on cost, and more or less completed the task in one go. Now moving on to Kimi K 2.6, 89 cents, second cheapest of the run. What set it apart from other budget tier models is test discipline. Built a comprehensive integration test suite, ran full scenario multiple times, annotated debug frames, multiple cycle validation. That was the exact same behavior I saw on Opus and Sonnet, not on the cheap tier. Caught the issues with FFmpeg, did the same precise diagnosis as GPT 5.5 made, tuned the human detection hog model specifically for 640 by 480 stream, because, quoting the project notes, the CCTV view at this resolution produces small figures that yield lower hog confidence scores. Reasoning was right, but boxes still sloppy. But this model stood out as it did the project in one shot, followed the Sonnet test discipline at GLM tier prices. DeepSeek V4 was also released recently and has been in the news. However, this was not the test where this model shined. It turned out to be the most expensive model tested. It took $3.43 on discounted OpenRouter's pricing to complete the project. Would have been higher at full rates. Burned a lot of tokens, was really slow, and kept timing out. It located the switch quickly and then got stuck for a long time figuring out how to actually control it. It tried Tiny Tuya Python module and then thought it wasn't working, and then wanted to write whole Tuya protocol from scratch. Required me to push it. I asked it why you were struggling to get it unstuck. The model needed multiple nudges to carry out the task. I was not able to test it thoroughly as it kept timing out. I was not impressed with the model. Maybe I will try it again after some time when the bandwidth issues subside. Scoring primarily 2 numbers per run. Total cost, one shot pass, yes or no. Total time was also tracked, but that was not very accurate and hence not a decision maker. There was no subjective coding quality scores in the headline numbers. I'll talk about quality in the final verdict. Finally, the headline results. Almost 7 models were able to carry out the task in one shot. When we compared the models that completed the task based on how much the task costed, 2 Chinese models shine: GLM 5.1 and Kimi K 2.6. GLM 5.1 at 75 cents and Kimi at 89 cents. Just a reminder, Kimi K 2.6 took almost 65 cents to complete the task and then spent some tokens to test it out and spent additional 24 cents. Other models and their cost to complete the task is mentioned on the table on your screen. Based on the test, GLM 5.1 seems to be a clear winner and Kimi K 2.6 is a close second. So finally, coming to my verdict from the extensive testing that I've done, Opus was able to complete the project and used all the right tools and models to carry out the tasks. When it was running through the process, it looked like an expert at work. The result produced was flawless. Human detection worked every single time. GLM 5.1 was also equally good, but the human detection model that it chose was not the best decision. GPT 5.5 results were also very good, but its correct human detection rate was much lower than GLM 5.1, which was almost similar to what Kimi K 2.6 was able to achieve. So all of these models are almost right there at the top and may need more difficult test design to actually test them thoroughly. However, as mentioned earlier, I love OpenCode as harness. So going forward, I think I will be using Opus more for planning and either of those 3 models for actual execution. Currently, I would avoid using Grok 4.3 and DeepSeek V4 Pro as they were not very good at instruction following or completing the task. But I would give them another chance, hopefully sometime soon, to test out whether my observation in the first test was right or not. Let me know what you think about this test. Which models do you use, and did this test help you with your model selection process? Next, I'm planning to run a similar eval on local open source models, Qwen, Gemma, the Mistral family. Similar prompt, same harness on the hardware that I own. If you want to see that one, like, subscribe, you know the drill. Thanks so much for watching.